Welcome back to Saathwic Infotech AWS Learning Series. As part of this learning series, we are in our day 8 session. So initially we started our session with understanding AWS, and then we understood like what is EC2 service. We understood what is subnet, security groups, VPC, and everything. And then we moved to our use case where we initially we build our simple AWS architecture where there is an EC2 machine which is hosting a website and reading the images from our S3 bucket. And then we went ahead and specifically created EC2 instances based on role based access where we have associated S3 full access role where our EC2 automatically downloads the complete build from S3 bucket and then hosted our website. So as part of our today's session, we are going to see something about new in our session, which is nothing but our elastic load balancers. Because like from the day one, we are speaking about like okay regions, availability zones, and we will be speaking about like multiple servers, right? So how these multiple servers are connected, or how these multiple servers are load balanced, so that user can access to any one of these servers in case of congestions, right? So how this architecture has been designed. So basically, as we discussed earlier, we are going to use the same architecture where we have three availability zones, and the three availability zones are mapped by a single security group, and in each availability zone we have a separate subnet which an EC2 with S3 full access role. But as part of us today's demo, I'm not going to show you like S3 integration with complete focused, because like copying the file from S3 or loading the file from S3 is all like kind of a chargeable one. So I'm not going to do that part of our demo. But in today demo, we are going to focus much on our ELB, elastic load balancer. So how are we going to connect all these three servers to an elastic load balancer, right? So that's the main part which you are going to look at today. So after the completion of our today's session, you will be like understanding like how this complete architecture works. Okay, how the elastic load balancer does the load balancing between these three nodes, and how they are interconnected to the S3 buckets and everything. Okay, so without further ado, let's move on to the practicals, right? So as part of this today's demo, I am going to create first I am going to create two EC2 machines in the same availability zone and explain you about something like classic load balancer. Then I will create two machines in two different availability zones and explain you about like how the application load balancers works within AWS. So in AWS, we do have like multiple load balancers like network load balancers and dual load balancers, and a classic one which is a very old one. We will deep dive into all those things today. Okay, let me log into my console. Okay, hope you guys are clearing all the resources after everyday session. Ensure that you guys are clearing it out, or else you will be charged. Okay, be caution on that. Okay, let me quickly create two EC2 machines in same availability zone. So how am I going to do? Let me launch this instance. Guys, just ensure that you practice these activities every day. Okay, once you guys practice this activity every day, then only you will be like feel comfortable with all this UI and everything, or else it will be difficult with these options. Okay, let me go with Red Hat. Okay, so I'm going to use all the default settings, subnet and everything. So security group, let it create a security group, or maybe I can use the existing one if something is there. Yeah, there is some security group already there which we created, so I'm going to use the same. Okay, fine, I'm not going to change anything else. Let me add Apache web server configuration slash bin slash bash sudo yum update hyphen y sudo yum install hyphen y httpd sudo systemctl start httpd sudo systemctl enable httpd sys. Okay, Guys, if you are not aware of all those commands and everything, I have explained all these details in our previous session. I would highly recommend you guys to watch those sessions before continuing with this, so that you better understand what is the use case we have taken and where we are marching towards with, right? So I am going to create two instances. So just I am changing the instances to two, so that all the settings whatever I have given here will take care. Okay, launch the instances. Oh, sorry. So I am going to use my old keeper launch. So probably it may going to take you see, right, now it is launching two instances. Now those two instances will be launched in the same availability zone. Okay, there is a reason why I am doing that. Let me tell you that too. Okay, let us bring up the instances. Okay, this is C5, this is 98. Okay, okay, hopefully it will take a minute of time. Okay, so meanwhile, let us try to understand what is load balancers, right? Okay, let me open just two servers and explain you that. Just a moment. Let me delete all these duplicate. Sorry, delete. Yes, delete. No. Yes, delete. Yes. Okay. Let me open up a session. So this is IP. EC2-user. My keeper. This is my keeper. Okay, let me accept this. Let me open a new session. Copy this one. EC2-username. Sorry, EC2-user. Sorry, my bad. Okay, private key. EC2 my keeper. Okay, so we already know that, right? When we use user data, system is going to perform those actions. Let us try to watch the log, what's happening behind the scene. Okay, let this run. Tail-f. Okay, let it run. Okay, so let's try to understand what is load balancers, right? So let's go back to our PPT. So now we have shift F5, right? Okay, so if you look at our PPT, we have three servers. Okay, at any point of time when there is an increase in number of users, okay, when there is an increase in number of users, even that time my load should split equally across my servers, so that no individual server is getting overloaded. Okay, that's the basic ideology of load balancer. Okay, in order to do that, there are multiple types of things, right? For example, if you want to do any load balancing for certain applications, like your web application or any of your software applications like informatica or any other things, right? So that's where you go with your application load balancer, so that it load balance at the EC2 level. Okay, there are something at network load balancer, which is load balance at the network level, TCP UDP level. Okay, this one does at the layer 7, that one does at the layer 4. Means that application load balancer work at layer 7. Okay, network load balancers works at layer 4 in the networking part, in under the OSI layer. Okay, if you guys are really not aware of like what is OSI and other details, probably you can check it here. OSI model, OSI layer, maybe you will see that, right? Okay, let me show you and explain that also, so that you better understand. So basically your application load balancer work at the layer 7, which is nothing but application layer, where it works and interact with the human and computers. Okay, there is something like transport layer, which is nothing but network level load balancer, which work at the transport layer, which works internally between the protocols TCP and UDP. Okay, and there is one more thing which is specific to AWS in initial days, which is nothing but classic load balancer. I will explain you all those details when our servers are ready. Okay, one second, let me go back to the servers. Let's see what is the status. Yeah, it's still moving on. Okay, it's still running our scripts. Okay, so just load balancer is service which ensures that okay, no individual server is like kind of overloaded. Okay, it split up the loads based on the certain algorithms, which everything we will be discussing when we actually look at our practicals. Okay, that's why today what we are going to do, we have two servers. I want to ensure that two servers are getting load balanced equally. Okay, so that my servers does not get high CPU or get up, does not go into like resource crunch when there is an IE load. We might have seen many times, right? So Facebook, when they open up a big billion days, okay, most of the time you cannot even access or reach the website itself, because it's all about the crunches happen at the server level. Okay, this particular load balancers ensures that there is no crunch. Okay, and also in earlier days we might have like 5 to 6 servers where the servers try to, the load balancers try to split up the loads between only 4 to 5 physical servers. There is no concept called auto scaling. The underlying server does not scale up based on the loads also. So now with the cloud we have all those features. So we will see all those things in our upcoming sessions. What is auto scaling, what are the criteria to do that and everything. For now just try to understand the basic concepts. Okay, so that we will, when we design a major architecture, you will understand. Okay, that's the main reason I want to provide everything in the form of architecture. Okay, when you guys design any architecture, you guys have to handle this like how to design and everything. If you look at the elastic ELB, which is at the VPC level. Okay, there is one more thing which is at the region level, which is route 53. Okay, you guys need to know the difference between route 53 and the load balancers. Many, when we go for an interview, right, many candidates mess up with the concept of load balancer with route 53. When we ask like, okay, how do you guys connect like multiple servers or everything, they just say okay, we use route 53 service and everything. Route 53 is not meant for that. It's meant for different reason. Okay, so load balancer is the one which helps you to balance the loads. Okay, let me see. Okay, I think the things are done for us. Okay, let us first validate like ps hyphen ef httpd, sorry, grep httpd. Let us validate like our server is running. Yep, our server is running. Let's see in this server also. Okay, here also it's running. So now what I am going to do, let me host a website. Okay, cd. Okay, before that let me log in as root. cd slash var slash www slash html view index.html. So what I am going to do, I am going to name this as first server. So just to feel that, okay, why I am doing this, the reason being is that when you connect to this website, okay, you should understand like to which server it's getting connected to. So that's the reason like I am just naming it as first server and second server. A simple website. Sudo hyphen I cd slash var slash www slash httpd, sorry, html, sorry, view index.html, insert h1 second server. Okay, let me save this. So now we have two server hosting a website. So I am creating a load balancer which should switch between these two servers and serve the user request. Okay, so let me quickly go and create ELB. Okay. Oh, it's going to features. Okay. Okay. So when you go to load balancers, there is an option called create load balancer. Okay. If you click on this create load balancer, you will see something like application load balancer, network load balancer, and gateway load balancer. Okay. And there is something like which is minimized, which is called classic load balancer, which is of previous generation. Okay. Now, so now what happened is we have created two EC2. Okay, let's see where it got created. Okay, the first EC2 is created in US 1B availability zone. Second EC2 is created in the same availability zone. Okay, so as part of, okay, let me, okay, first let me try to create a classic load balancer. Okay, because it was the previous generation one, but still many applications are still using it. So let me open a classic load balancer. See, it says we have redesigned the classic load balancer to make it easier to use. By default, always brings the new classic load balancer experience. You can access the old console experience too. That's fine. Let us use the new experience itself. So if you want to understand like how classic load balancer works and everything, they have given in theory. But we know like how it's going to route the traffic and everything now for now. So let it be. So let me create a load balancer. I am saying like okay, uh, my website, maybe fruits website, which you seen yesterday, right? Fruits website. Okay, so is that internet facing? Yes, because people are going to connect from internet. So I am going to select internet facing. Okay, so where our servers are specified, it automatically picked up the servers which is in US 1B. Let me select that. So it's under the same subnet. Okay, security group. We have a web server security group. Okay, and basically we are going to ask it to connect under port 80, HTTP port 80. Okay, it basically says like what is a ping path, it's index.html, and we need to select the instances. What are the instances are part of this particular load balancer? So I am going to add these two instances. Okay, it says the status is running. So it says enable cross zone load balancing, enable connection training and everything. Just have a look at that. Let me explain you what is this. Okay, if you are going for cross zone load balancing, okay, this feature has been like enhanced in our application load balancer, which is very new. In classic load balancer also we can do with cross zone load balancing, but for us both the instances are in the same zone because I want to separate that activity in application load balancer, so I did not do that here. Okay, hope you guys are understanding. So right now our EC2 are in same zone, so even you can uncheck this, no harm. Okay, then it gives you the summary. Let me create a load balancer. View load balancer. So whenever you create a load balancer, you should get the state here. Okay, you need to wait for some more time to get this load balancer created for you. Okay, the state should be published. Meanwhile, I will copy. This is going to be our URL going forward. Usually what we do, if I want to connect to any website, I will copy their public address and post it here so that it says second server. Let me copy this one, not this one, sorry. Let me copy this one and put it here. It will say the first server. But generally we don't provide the users with these IP addresses. We provide the users with a DSN name, basically like google.com or example.com or Saathwic.com, like that, right? So we don't go with a single server, because if I am connecting to the single server means that always I am hitting the one server, the second server is going to be idle. If I am hitting this server, the second server is going to be busy, first server is idle, which we don't want to do. That's where we are going for a load balancer. That's the main objective, right? So let me copy the load balancer URL. So whenever I put the load balancer URL, it automatically routes to one of the server. Okay, let me see if the load balancer is created. Yep. If you look at now, the load balancer routed me to the second server. So that's where you are seeing this message. Okay, let me refresh this one. Guys, closely watch this. You will understand. Okay, if you see, whenever I refresh, Certain times the load balancing happens to only one node. It's not going to the other node. Okay, it randomly defines that. Okay, classic load balancer, that's a problem. It balances. You got first one, right? So it randomly decides. Okay, you see now it's going now. I think there was some connecting to the first server was taking time. Now we have enabled round robin. So every time you connect, it goes to one server and the other server. First, second, first, second, first, second. So hope you guys understand, right? So this is the objective of the load balancer. Okay. But if AWS has come up with the latest thing, okay, before we move on to the other things, let me explain. So hey Kumar, like usually in our real time you will see something like lock key. Now it says not secure. Ideally our website should not be not secure, it should be like secured one. So you should see a padlock symbol here. So how do I do that? Because you shown me only for HTTP. How do I do it for HTTPS? Okay, when you define for HTTPS, okay, let me go to the load balancer, action, manage listeners. Okay, under listener you need to add, okay, where is the listener configurations? Okay, maybe I need to create a listener. Okay, here it is. So under listener you need to add one more thing for HTTPS, okay, which I will show you in a few minutes down the time. If you add for HTTPS, okay, when you create a secured website, it means, how does it getting secured? It does an SSL handshake. Okay, so you need to have a certificate generated. So there are other process which you need to do. We will show you, because for this it's not applicable. Okay, let's try to understand the concept of load balancer. Okay, if time provides I will explain you all the SSL today, or else I will show you maybe tomorrow, because we need to create a certificate, we need to download the certificate, add it to the servers and everything. We need to do few more configurations. I will show it probably tomorrow. That would be a better option. For now we try to understand. So this is a classic load balancer. Okay, let me go here. Let me click on load balancers. Okay, for now let me delete this load balancer because I don't want classic anymore. Hope you understood the classic. Confirm, delete. Okay, so while creating the classic load balancer, do you guys seen any issues? Okay, you guys have to think about it, but we have not gone through the topic yet. So probably if I ask also, it will be like maybe you guys might have to think and tell. Okay, so there is a problem with classic load balancer. What happens is we have manually added the servers. For example, anytime, see for example, I explained you about the big billion day issue with Flipkart. So if I have enabled auto scaling, classic load balancers, you think it can handle? No, because we are manually adding the instances to the load balancer. Okay, that's the main problem which got addressed in the latest load balancers which is created by AWS, which is nothing but your application load balancer. Okay, let me show you how they handled it. They handled it in a minor different way, nothing much, because like if you are doing any changes with the load balancers directly, it might impact your user. So that's why they handled it in a different way. I will show you how it they handle. Okay, let me create an application load balancer so that you will understand. Let me create the same fruits website. Okay, again all the details are pretty much same. It's internet facing, and also if you look at, it supports like IPv4 and IPv6 both addressing methods. Classic does not do. So I am going IPv4, and again it uses the same. Okay, and by default you will see one more changes. So all my servers are in US 1B, so I am selecting that. Okay, I have selected one subnet, security group. Let me change the security group. Again let it be the same, but if you look at here, I am selecting HTTP port 80. It is asking me to select something like target group. So what is target group? So here target group is a different entity, okay, which will associate the servers into a group, and that group get assigned to your load balancer. This is specifically created for handling the issue which I mentioned in the classic load balancer, because when you are scaling up with auto scaling or something. Okay, see here, you see, right, facilitate the use of Amazon auto scaling. So when you are using auto scaling or anything, it the target groups get updated automatically. Okay, that's the main reason. So I am going to create a target group name based on the instances. My target name is like tg target group web servers. Okay, it's going to use the port of this. The VPC is this, and the protocol version I'm going to use the same. I'm not going to use the latest versions. Okay, health check path it's asking. Let me put like index. Maybe I think this is also fine. Okay, next. Okay, iPhone is not allowed. Okay. Okay, next. Now I am going to add the servers in the target group level and not here. Okay, and also if you see the servers are running, but this target group internally try to validate whether the servers are reachable. Okay, that's why it says add include as pending. So I have added. It will check the else checks even before adding the server, and ensure that, okay, before routing, if the server is live, only it will route if the server is alive. Okay, I am creating a target group. Okay, let's validate if what's target group says. If you see, it says totally 2 target added, healthy is 0, unhealthy 0, unused is 2. Now my servers are in the status of unused. It should be available. Okay, once that is available, then only your load balancer will start working. But meanwhile it comes, let's start creating the load balancer. So I have created the target group. Let me refresh this. Let me pick up the target server, sorry, target group. Okay, basically that's what I mentioned, right? If you want to add HTTPS, you have to click it here. Sorry, you have to click it here, which probably I will show you tomorrow. Okay. So then it says like you want to add like global accelerator to get the static IP address and other things, which you are not going to do because we have not discussed to that extent. Okay, let me create the load balancer. Here comes the tricky part. Okay, in classic load balancer, you got an option of selecting the servers within the same zone, within the same subnet, but application load balancer does not allow you to route the traffic within the same subnet. Okay, you should at least have 2 subnets. Okay, so it's saying like, okay, you don't have 2 subnet. Okay, basically my architecture does not want to do. So for me, the classic load balancer is the appropriate one. You got it? So now what I am going to do, I am going to launch one more instance. I am going to launch it in a different availability zone. Web server 3, Red Hat, my key pair. Okay, see here it says no preference, right? But I don't want to. I want to create it in a different availability zone. So subnet, create a new subnet. Select the VPC ID. You understood, right? Hope you guys are now clear with what is CIDR block and how to give the CIDR blocks and all. Hope I have covered in one of our session. Okay. So my subnet name will be like US East 1A subnet. Okay. So it says availability zone no preference, but I want it to be on 1A. Okay, in a different zone as per our architecture. So this is VPC CIDR block, which I don't want to do, but subnet CIDR block I need to do. One 172.31.64.0/20. So basically I have explained you how to do all those things like CIDR block and everything, how many IPs are available, everything I have explained in my earlier sessions. Okay, so I don't want to spend too much of time in like how did I came up with 64 and everything. which I don't want to explain at this point of time. If you guys really interested how these 496 IPs are came and everything, maybe you can get in touch with that. Okay, let me create this sub. Okay, there should be one more thing. Internet facing something I need to select. To availability zone. This is okay. Keypair. Okay, let me create a subnet. Then I will see. Okay, my subnet got created. Okay, public IP address. It should allow everything. IPv6, v4, action, edit subnet settings. Yep, we need to use this, but enable auto assign IPv4 address because we need public IP address. Without that, it's not going to help you out. So you need to select that, save it. Then only your EC2 will get an IP, public IP. If you are using this subnet, or else you don't get. That's what I was looking for. Okay, let me quickly create an instance. Okay, I was in instance creation process. Let me refresh this. I should see my subnet now. US East 1A subnet. This one I want to select. Auto assign public IP enable as came now. Security group. Select the existing one. Select the same web security group. Okay, let me go here and add the web server configurations. Bin slash. Okay, good. Let me launch this instance because I want only one instance. By this way, my load is getting splitted within as per my architecture. Now I am created one EC2 in availability zone 1 and another EC2 in availability zone 2, which I am going to use the earlier one. So which is US East 1B and US East 1A. Okay, and I have created separate subnet in both the availability zones. Now I am going to use the same architecture in ALB. Okay, application load balancer. Okay, let's see. Okay, let me copy this IP address. New session. EC2 user. This private key. Okay. PS-EF. Okay, let it do its processing. I need to add this to our target group. Let me do that work now. Where is our target group? Okay, here it is. Let me refresh this one. It's still in the unused state, that's fine. So let me click on register target. Okay, this is a web server 3 is our new server. So let me include as pending below. Register pending targets. Okay, now we have 3 target to do a load balancing. Maybe if I want, I can remove one. Let me remove this. Okay, great. So now I have one from each zone. One is from US East 1A, US East 1B. So just to keep in sync with my architecture, nothing different. Okay. So where is my load balancer? Okay, here it is. So let me refresh this one. Okay, now I have two. One is from availability zone A this subnet and one be this subnet. Both are different subnets. Okay, I have selected it. I have selected this one. We selected our target group. Everything is fine. Okay, let me create this load balancer. View load balancer. Okay, this is our thing. Integrations. We don't have monitoring. We don't have listener and rules. Okay, we have to check it in the target group. Okay, let's wait for this because this is going to take a little more time because your target group will do everything. Okay, now it's came to initial. It has to go to registered state. Basically, it will be like available. It should say. Uh, okay, let me try to see what happens if I connect to this load balancer. Okay, this is my load balancer name. Okay, before that, this server is getting connected. Yes, this server also will connect, but I don't want to do with this server anymore. So, what are the servers I have added? Okay, let me copy this one. For this one, we should see that Red Hat thing. If the things are done in the server, so still it's going on. So if the installation and everything is done, then only like our target group will even recognize it. Okay, so let the things complete on the new server so that the ping and everything will be validated by the target group. Okay, let's wait for a couple of minutes so that this work will be done. It is 67 IP address, right? Okay, this is a new one. Yep, you see, right? So for this one you got as healthy. Okay, for this one you got as unhealthy. The new one is saying unhealthy. Why the new one is saying unhealthy? Because like new one still we have not configured our web server itself. So that's the reason it could not able to connect to that particular area where slash www slash html. So that's why it says unhealthy. Probably in another 1 or 2 minutes it should be healthy once you configure our website here. Okay, got it. So now even now one is unhealthy, right? Even now our website will work and our DNS should work. That's again a good use case, right? Let's see that. You should see second server or first server. I don't know which server I have included. It takes some more time. This is second server, first server. The new server is not configured, so it should take you one of the server which is old one. Let's see. Okay, still I think load balancer is not ready then. Let me check the status of the load balancer. Okay, it's active. It should work by this time. Because initially it will be in provisioning state. Okay, if you go your load balancer, it goes to provisioning state and it has to come to active. Now it's active. Probably it should be showing it now, or maybe I will refresh it now. It should pick it up. It should route the traffic to the healthy server. Meanwhile, what is happening? Okay, here also it's done. Sudo -i cd slash where slash www slash html. So I am going to add it as like the third server from A zone. Okay, so we have done the settings. Okay, still I think something happening in the behind the scene. Let's validate that too. So let's go back to the target group. Let us refresh. Okay, both came to LT now. So let's validate this IP address. Okay, third from A zone. So let me try to refresh it again. Looks like something wrong in our ALB creation. Let me double check. Okay, target group shows both of them are healthy, so there should not be any issue. Load balancer, let me open the load balancer. So basically, like when you guys work on the load balancers, you should try to understand like how things works, right? So when I try to connect the fruit website, it's not working from my local, whereas the individual servers are like currently working. So probably the reason which I assume should be something with our security group or networking. Let's see. Okay, this is our security group assigned to our all traffic, all range. Okay, I got it. So basically it allows all traffic, all range, but it's not specific. I think it assigned the wrong one. 1 second. I think I got it. Okay. So basically we have a security group which allows HTTP and HTTPS connection, which is our web security group. So rather than this, we assigned our default one. I think that's the issue. Let me assign this and refresh it once. Okay, 1 second. Now let me try it out. Yep. Okay. I think the security group is the issue. So security group was not allowing the HTTP traffic. Okay, that's where. So now if you look at, now we are going to third server from A zone, first server, which is in our zone B. So you see, this is getting routed. Okay, great. So as part of our today's session, what are the things we have seen? We have seen what is a load balancers, okay, and what is the use case of it, and then how to create a classic load balancer and what are the issues with your classic load balancer. Okay, basically classic load balancer by default route within the same availability zone, and even it allows you to do it within a single subnet. Okay, and also classic load balancer, the drawback is like, okay, whenever you want to add a new server, you need to add it to the load balancer where you are disturbing your load balancer settings. So there will be a few glitches happening during your user communication. So in order to avoid all those things, okay, they came up with something like application load balancer. Okay, in the application load balancer, they handled this issue with the help of target groups, and with the help of target groups, it can even add as much as server based on your auto scaling groups. Okay, as we have not seen our auto scaling group, so I don't want to confuse you guys too much with that. So basically this is a separate entity where we are going to add our new service whenever it's getting created, so that we are not even disturbing our application load balancer. So there is other load balancers like geo and network load balancer. I'm not sure whether I can give you the demo, but tomorrow session I will show you how to work with network load balancer and geo load balancers, and what is the purpose of it, when to use, and everything theoretically. And also I can show you like how to use HTTPS connections, because for HTTPS connections, for example, you see the AWS symbol, right? You see a padlock symbol. So if you want to get this HTTPS connection where you need to have a certificate authority, okay, and everything. So if you are registering an external certification authority, then AWS is going to charge you. So in our case, we are going to use AWS certificate manager, which is ACM. So all those things I need to explain, so I will cover those details probably in our tomorrow session. Until then, okay, if you guys really like this video and if you are learning even a single new thing, I would request you to subscribe to my channel and like and support me, so that I can better cover other topics too. Thanks for watching.